So multimodal, it was a perfect introduction to the, my presentation also, because you know, the multimodal, I think it's important, and in fact these are my disclosure, but probably the most important disclosure is that I'm a multimodal imaging supporter, so I can be biased, you know, so take with some risk what I will say. So this is the new Mirante, and if you want, this is a picture, but if you want to see in real, you know, touching, it's at the NIDEK booth. And it will be available, I think it's already available in the market starting yesterday or today. And the advantage comparing with the F10, it's that it's has the same you know, characteristics, but particularly the tilting mechanism and the swinging mechanism allows you to move the head, the optical head, so you can actually get in the periphery much easier than not with the F10. The possibility to use many different wavelengths, the infrared, red, green, and blue, combined can actually give you some interesting images. And just to give you some example, with the color images, it's not real a white color image, so it's not obtained by white light, but is obtained by 3 different wavelengths: red, blue, and green. And the interesting part is also is a confocal, and we will see why confocal is important. It gives you a more sharp image and more and better details. But just to compare with all the color images that you can actually see in the market, you know, there are normal flash camera like a Canon and Topcon using a white light. Then we have the Optos, that is actually a 2 wavelengths, blue and green, and the software is putting together. Then we have a LED slit light confocal of the Adon. Then we have the Clarus, the new Clarus from Zeiss, that it's a broad line fundus image, similar to the slit light confocal. Then we have the Spectralis, that is a scanning laser obtained with 3 wavelengths, the blue, green, and near infrared. And this image is called multicolor. And then we have the scanning laser 3 wavelengths, blue, green, and red of the Mirante. Just to see how, you know, the images can be organized, you know, the difference between the multicolor from Heidelberg and the color from Mirante is this image. You know, they're using the near infrared instead of the red channel. And the reflectivity, as Thomas told you before, it's a little bit different from infrared to red. So what is absorbed by infrared is actually reflected by red. And combining the images, it can have some differences using a multicolor with Heidelberg, different from the normal color image that you expect from the ones that use a red channel like the Mirante. And of course, you can actually expand and having a wide field image obtained exactly in the same way. By the way, I have not to ask any disclosure because this is my eye, so I should take and show all the images without any problem. Not this one.
I hope not.
Lucky enough. So what about autofluorescence? You have 2 autofluorescence, the blue and green, and which is the difference between the blue and green? But the most evident is the fact that you have, of course, the macro pigment, which is a yellow, and so it's absorbed by the blue light. And in fact, you see here the dark spots, and here you don't see the dark spots. So when you use a blue light, if you want to know if there is still some RP cells under the fovea, you are masked by the macropigment, by the absorption of macropigment. So if you use the green channel actually you can actually see much better the RP situation. And of course, if you combine, you can actually measure, if you want, the macropigment density. And you see that you know, the rest, it's exactly the same, but not the central one where we have the macropigment presence. Then we can actually use the infrared reflectance, and infrared can be you know, just a reflective image, a direct confocal image, or a retro mode image. I tried to explain, you know, confocal aperture allows you to take, if you project the light, to collect all the lights that come from the layer that you are interested in, discharging all the lights that come from the surrounding area. The retro mode is actually exactly the opposite. It's stopping the light from the layer that you are interested in, and you are taking images from the light that comes from the surroundings, so a kind of retroillumination. So here, the same case, where you actually see the confocal infrared reflectance. Then you have the retro mode with the round shape, so you take all the lights, and if you move you know, your hole just on the left or on the right, you have actually kind of, I don't know if you have ever done some microscopy study using the Normoski technique, but it's actually kind of illumination that show bumps like you see here. And so, for example, in this case where you actually see some reticular pseudodrusen here, but usually the best way is to see with a confocal infrared light. You see some of those, but they're much better visible and probably more than what you see with a direct light. You know, the reticular pseudodrusen, that, as Thomas says, it's very important now in identifying for prediction of outcome of your treatment and the patient. And here some other example of the color, direct infrared, and the retro mode. And you see that it's clearly that the retro mode is showing much more the changes at the level of the retina. And here another example, but Professor Sada will speak much more about that. Then you have the OCTs, and here the OCTs, it's, I would say that I like the Mirante particular to show the vitreous, and then this is why I'm actually focusing on the vitreous on this image, that also you can actually use the color, and you see all the fibers of the vitreous, and also the part of the detachment and the wrinkling of the limiting membrane. And here, choroidal vascularization and the two auto OCTs showing exactly the direction of your scan. What about OCTA? This is a 3x3 OCTA, again of my eye, and you see the avascular and the choriocapillary area. What about fluorescein angiography? It's possible to do a dynamic fluorescein and ICG angiography, combined or just one by one. And I took only images here, but you see that you can actually get then from the movie the different frames, and you see this type 2 CMVs with the edema quite clearly seen here, and the same the ICG of this patient, and you see that the details of the choroid and the retina are quite nice because of the confocality of the instrument. Just to go through some cases, here is a type 1 CMVs, and you see the color with the hemorrhage, the infrared, the autofluorescence, the fluorescein and ICG, and the blue, and again you see the dark spots, but is not hemorrhage. This is hemorrhage, if you have some doubt. and you use just the autofluorescence, just go and see the green, and you see that there is no the dark spot in the center. And here the retro mode of the detachment. A type 2 CMVs, you see the color, again, the infrared, the red-free, with the autofluorescence, the fluorescein, and the ICG here with the phase of, of all the net, very well visible over here. A type 3 with the hemorrhage seen in a color. In a red-free, you have autofluorescence, fluorescein, ICG, and the OCTs. Again, the two autofluorescence with the green now. And you can actually see your lesion with the masking effect of the hemorrhage here in autofluorescence, and the leakage in ICG, in the late ICG, which is typical of the RAP lesion. Another case of RAP, and you see again, in this case, I put the retro mode with the detachment and all the reticular pseudodrusen that are actually typical of a RAP lesion. So if you have reticular pseudodrusen, you have to think about a RAP lesion, and you see that it's not visible in the other modalities, but it's quite nice visible here in retro mode. And the OCTs, quite clear. Branch retinal vein occlusion. Again, look at the retro mode showing the cyst of edema that correspond to the autofluorescence. Of course, in this case, you have to use the blue autofluorescence because the cysts are seen because of the displacement of the macro pigment. So you see the fluorescence that comes from the RPE, partially masked by the movement of the macro pigment that are showing exactly, the macroedema. And here, a non-proliferative diabetic retinopathy. Here, just a fluorescein angiography of the patient. Here, the images of the mid and late phase. So this is actually what you can do with Mirante. The advantage of having everything together allows you to move from one to the other. And then again, having the idea that if you know exactly what the single image can give you as an information, having all the possibility to do everything in one shot is very useful to do a fast and a correct differential diagnosis. Thank you.